Coming up on This Week in Radio Tech, it's a great show. Paul Shulins is joining us, along with Chris Tobin. We're talking about precision VSWR protection so your transmitter doesn't turn into an arc welder and burn up $1 million worth of Feedline. Holy cow. And some precision drone flying, too, to get great infrared pictures. It's all coming up on TWiRT.
This Week in Radio Tech is brought to you by Broadcasters General Store with outstanding service, savings, and support. Online at bgs.cc. By Angry Audio. Audio problems disappear when you get angry at angryaudio.com. By Nautel, keeping you connected with your community with support and webinars. Online at nautel.com/webinars. And by Max Connect Wireless, prioritized high-speed internet service designed for transmitter sites and remote broadcasts.
Hey, welcome into This Week in Radio Tech, the show where we talk about everything from the microphone, like this one, to the light bulb at the top of the tower. I'm Kirk Harnack, not in the usual Telos Alliance studio today. Instead, today, I'm at One Station Studios in Mississippi. I'm at Delta Radio in Greenville, Mississippi. This is Studio B right here, where I've been working to resurrect, to rebuild, I should say, this kind of old Frankenstein Axia console. It's almost 15 years old, and we've just bought pieces and parts here and there and made it work for a second studio. So that's where I am today, coming to you from the home of Delta Radio. I think we're running 5 radio stations out of this building, and the air conditioning can barely keep up. So it's a hot, humid summer Mississippi day here, and let's see what's going on with Chris Tobin. Chris is in New York City, I suppose. Chris, how are you?
I'm well. It is a hot, humid day here in New York City as well. Cloud cover is starting to roll in, so I guess the stormy weather may be coming. These nimbus cumulus clouds are growing, which I usually think that means a change of weather, so I guess it's going to be fun. Should be a good time today. But yeah, all's good.
Hey, Chris, as usual, we're going to make a quick announcement about the Nautel Transmission Talk Tuesday thing. They had one this past week. It was, or this past Tuesday. It was a good thing on this past Tuesday about audio processing. Next week, minimizing operating costs. You know, there's CapEx budgets and there's OpEx budgets. OpEx is the ones you pay about every month. And this week on Transmission Talk Tuesday, the roundtable discussion is about minimizing operating costs. So it's going on Tuesday, July 28th at 12 noon Eastern Time. You figure your time from there. You need to go to nautel.com/webinars to register, and they'll reply to you with a calendar reminder. You can stick in your Google Calendar or your Outlook calendar. It's an age-old question, how to minimize costs, and the section will be all about working to get more bang for your buck at the transmitter site, from more efficient equipment, spectral efficiency optimization in the FM, using FMHD, MDCL in AM, and other ways to squeeze more savings out of that technology. Now, Jeff Welton is going to be joined by Mike Pappas from Orban. So Mike Pappas will be there. I've known Mike for years. He's a smart engineer, and of course, so is Jeff Welton, talking about minimizing operating costs. Chris, I got to join this past Tuesday for a little while. I hope that you'll be able to join the one next Tuesday for minimizing operating costs. What do you think?
I'm planning on it. I have to register, but I have it on my calendar, so I'm going to make time for that. Yeah, absolutely. That's a good one.
Good deal. Well, Nautel's been doing this as roundtables, so you get to ask questions. Yes, there's expert hosts and guests, but you get to ask questions as well, and so it really is worthwhile. And people, as far as I can tell, the engineers who've been joining it really are liking it. They appreciate Nautel doing this. Oh, one more thing. They're going to be extending these popular interactive sessions through August now. So more topics are coming soon. They started this out wondering, hey, what's the response going to be? And every week the response has been great. You engineers, friends of ours, people who watch the show, thank you for tuning into the Nautel webinars. Register again at nautel.com/webinars. Okay, Chris, we've had Paul on before, Paul Shulins. Let's bring him in again. We've got some cool new topics to talk about. Paul, welcome into This Week in Radio Tech.
Hey, Kirk, thanks so much. It's always an honor and a pleasure to be on your show. Episode, 503? That's amazing. Congratulations. I don't know how you have the discipline to do it every week and do it so well, but this is a lot of fun for me, and thanks for thinking of me and having me on. I really enjoy it. And by the way, that Axia console in back of you, that looks brand new. I know it's 15 years old or something, but some things are timeless. That's awesome.
It's actually got different eras of modules in it, so there are different color schemes. But hey, the people who use push the on button, they move the faders up and down. That's all they need to do. By the way, Paul, thank you for your congratulations on our 503rd episode. This is me scratching my head, right? I'm scratching my head. You know what I'm trying to figure out? I'm trying to figure out how in the heck Chris Tobin has put up with me for 10 years. Chris, do you have an answer for that? I'm really scratching.
I think the phrase is patience is a virtue.
Is that you're talking about your patience, right? Not mine.
My patience. I work with announcers. I work with DJs all my life. I've worked in newsrooms all my life. I mean, you want to have issues with people and the way they act. I mean, work in a newsroom for about a year, and you'll understand how to deal with stuff. But yeah, no, working with you is a pleasure. I mean, come on, we have a good time doing this stuff. I speak my mind, and you do it very nicely.
Hey, we've got several topics to talk about, and Chris, I understand that because of another commitment that's popped up, you can't be with us, but for another 5 or 10 minutes or so. So I want to jump right into this one that I know applies to places that you take care of, Chris, but not so much to places that I take care of. And so Paul is going to talk about precision VSWR protection systems, and what happens here, and Paul, why don't you start in? But I'm going to ask Suncast to start popping up a few of these pictures, and we'll talk about them as they come. In fact, I think we'll tell you what, Paul, just set it up. Tell us what this RF VSWR protection systems are. They're typically on master antennas where you have a bunch of people with a bunch of money invested, and we don't want things to go up in flames. So talk to us about what you're doing with this.
Sure. Well, master antenna systems are not new. They've been around for 20 or 30 years, but they're getting even more and more popular every day because of the rising cost of real estate. And also it's a very smart engineering solution because you get rid of a lot of intermodulation products, and a lot of people get to share a master antenna system where you're able to put together something that's very well engineered, and that's something that individual stations couldn't afford. Of course, when you do this, you have a lot more at risk because there's a lot of money involved in the combiners and the transmission lines and so forth. So what has popped up recently is the need to protect these systems. And of course, it's always been a need, but nowadays with especially the TV repack, which I've been drawn into with a lot of the work I've been doing, which is now concluding, and that forced a lot of TV stations to change frequencies and transmitters, and a lot of that was funded by the FCC. But along with that came new transmission lines and new antenna systems and new combiners and all that kind of stuff. And what they took the opportunity to do here is to put in some of the equipment that I've been working on, which is VSWR protection. And for those who are not familiar with the VSWR protection, what it is looking at the energy that the transmitters are putting out, and hopefully all that energy goes into the antenna. But if things aren't tuned properly or things change with the transmission system, some of that power can be reflected back. And when too much of that power is reflected back, there could be damage done to the transmission lines and the system, which could run into the hundreds of thousands of dollars or millions of dollars. So it's worth it for broadcasters to put in a system that will detect these problems early on and shut down the system. Even though nobody wants to go off the air, it's better to go off the air, fix the problem, than to stay on the air and potentially burn up a lot of good transmission stuff. So that's kind of what I've been involved with, designing systems and installing systems that detect reflected power and what we term VSWR. Those are the standing wave ratios of the power that comes back to the transmitter that's undesirable, and reports on that. And it also is interlocked with the transmitters so that it automatically will open up the transmitter interlock and make the transmitter stop producing the RF power so that there's no longer any energy available for damage to occur. This is a picture. Yeah, go ahead, Kirk.
Yeah, I was saying, hey, Suncast, let's get picture slide 3 up there, which shows not that. Yeah, we'll go back to those other 2 later. Let's start with 3. There we go. What are we looking at here, Paul? And I'm going to save my question for later. Looks like there's some Cat 5 cables here and RJ connectors, as well as something to measure forward and reflected power.
That's right. So you're looking at, this is a FM combiner, and this is one of the 6 input ports. This is actually up on Tiger Mountain in Seattle. And you're looking at an ERI directional coupler. And what this coupler does is it extracts a very small RF sample from the energy going through that 3-inch transmission line. And you're looking at these silver rectangular boxes that are screwed onto the side of the coupler by a type N connector. And those are actually RF detectors. And what the one on the left is for forward power, and the one on the right is for reflected power. That's the green and the red wire coming off. And basically that is, there's some magic electronics in those detector boxes that will output a precise DC signal that is logarithmically proportional to the RF in each direction. And these signals go back to some of the equipment in the rack that looks at that number very carefully and calculates at a rate of 10 or 15 times per second what the reflected power is. And if it exceeds a preset safety limit, which is usually a technical number at 1.35 to 1, it will open up the interlocks and prevent the station from producing any RFs so that no damage occurs. So this is a typical setup. We have 6 inputs for this particular combiner and 3 outputs to the combiner. There's an upper and a lower antenna, and before that there's a power splitter. And so we're monitoring the 6 inputs and the 3 outputs simultaneously. And we know exactly if there is a problem, where the problem is. And if it's an input, we can only open up the particular one station that has the problem. Or if it's an output, we open up all the stations because we don't, all the stations would be contributing to the output power where there could be a problem. So it's a very intelligent system. We've got a picture there of the display. Well, yeah, I can describe this. This is where all the connections come back to from all those couplers in the previous picture you just saw. So those DC samples come back to these modules. They're called ADA modules. They're data acquisition modules that actually measure the precise DC voltage, and the computer then reads that information off of a RS-485 bus and does all the calculations and displays it on a screen. So this is basically the system. On the other side of the rack, this is the rear of the rack you're looking at, and all those Cat 5 cables that you see are basically the wires from all the sensors going around. And thanks. This is the photograph of what the front of the unit that I'm installing looks like. And there's customized software on each different customer. This is, again, up at Tiger Mountain. And you're seeing in the upper left-hand corner the upper antenna power and the lower antenna power right below that. And on the right-hand upper corner, you're seeing the output power of the combiner before it gets split. And then the individual stations, you can see their logos down below. And the numbers you're looking at indicate the forward power and the VSWR. And the reflected power is a little too hard to read because it's in a smaller font, but it's shown there as well. So when you walk in the room, this is the first thing you see. And it generally, gives you a quick indication of the health of the system. At the very top, you see a key switch that's labeled Operate and Lockout. And this is a safety feature. In case you have tower climbers on the tower, you would use the key switch and move it to the lockout position, and it would open up all the interlocks so that no RF could be produced and the tower climber safety could be ensured. and then there's a green button there to reset the interlocks in case something trips off. So really, this is just the face of the system. There is a lot of stuff that goes on in the cloud because the system reports to the cloud, and there are
Really?
real-time
Wow.
web pages and stuff that the engineers can look at anytime they like to see what the health of the system is. We look at the gas pressure in the line. Those transmission lines have usually dry air or nitrogen, and it's important that those lines become pressurized and stay pressurized. So if there's a leak, the system will report the leak and that kind of thing. So we're looking at trend information. If something is going in the wrong direction, but it's not yet at a dangerous threshold, we'll report that. So it gives us kind of a heads up, in terms of time frame, so that we catch things before they become real problems.
So hopefully we're going to catch Chris before he has to leave. But Chris is involved with Master Antenna Systems himself. Chris, before you have to go, I just want to get your thoughts and comments, and maybe a follow-up question for Paul before you have to go.
Well, I'm quite familiar with the systems that Paul just put in, has maintained there, and several others. But yeah, the several sites I work at, we have master antenna, television, and radio, and VSWR is critical. We've had a few cases over the years here in New York City where basically somebody's transmitter didn't have an interlock that would cut out because of a failure somewhere in the system, and it pretty much was an arc welding machine and took out a good piece of transmission line and a diplexer. So yeah, it's an interesting, it's a very important, quiet, nobody talks about process that's necessary in transmission. I mean, both for broadcast and even other types of microwave transmissions as well. I mean, it's all there. But broadcasters especially, the TV and radio, and what Paul showed there is exactly what you want. Straightforward, tells you right away, forward, reverse, your VSWR, everything, you know what's going on. You're in great shape. Return loss. I mean, one of the ones I maintain, two of the ones I maintain, we have forward, reverse, pressure on the lines, return loss numbers, all kinds of stuff. So anything that changes, because it's static, it shouldn't really change. You know right away something's shifting. In the early days of installation of one of the sites, we came across a couple of split bullets as a result. We found out later on, so it's handy to have that information. And having it in the cloud and access anywhere is even better.
Yeah, I have to say, I've been involved with the TV repack, and there's a couple of dirty little secrets that should be understood with transmitter manufacturers. And I did a little talk with Jim Stenberg at IEEE this past fall before the pandemic hit. And if you don't know Jim Stenberg, he's an absolute genius, and it's a pleasure to have worked with him and continue to work with him. He works for American Tower Corporation as their principal RF engineer, and he was actually the recipient of the NAB TV Engineering Achievement Award this year. So that was quite an honor. But Jim and I, have had a lot of experience over the last couple of years with the repack, and unfortunately, we've seen a lot of transmission line problems and incidents that have happened when new equipment gets installed, and we have also determined one problem that really hasn't been talked about, and we brought this to the attention of transmitter manufacturers, is VSWR foldback in the transmitters, because the transmitters are supposed to help out with this by folding back the power when they sense a problem. But in fact, sometimes this can work against you because the transmitter will fold back to a lower power, but it'll just stay there at that lower power and continue to run. And if the problem is such that there is a arc or potential for burn in the transmission line, it will just continue to make power and burn. So these interlocks that we're talking about here are really important. And we hope that transmitter manufacturers will change a little bit about how they do their VSWR foldback, and maybe sense on reflected power rather than just VSWR.
Interesting. Chris, I can imagine you've got some, there are sophisticated systems out there and less sophisticated systems. I need to ask Chris, do you have to go now, or do you have a few more minutes?
I got another 5 minutes.
Oh, okay, okay. Well, so what I'd like to understand, since Chris, you deal with these, and Paul, you deal with these, and Paul just partially answered this already with regard to transmitter manufacturers, but I'm interested in the very sophisticated systems that Paul deals with, and what preceded that. And Paul can answer that too. But Chris, before you go, I'd like for you to talk about what has been less sophisticated. And I'm guessing, hey, when I first got in this business, I had engineers tell me, that Gates FM H3 transmitter there. That's transmitter so good, it'll just arc weld an antenna, if something goes wrong. Like that was a good thing. I don't think it's a good thing at all. That thing will be an arc welder if you're not careful. Well, we don't want that. We don't want to destroy the transmission line. So, Chris, what level of sophistication have you gotten into there in the New York City area? And then we'll eventually get back to Paul to talk about the steps that he's taken to move this forward even more.
Oh, you're talking about the Energionics transmitters. Yeah, the grounded grids.
Well,
those are
perhaps,
arc welders. Yeah. Well, no, I mean, early on, the early days, we had simple reflected monitoring, DC voltage, and a trip point, and you basically shut your transmitter off. Nowadays, you can actually watch it, in a logarithmic way. So just as Paul pointed out, those new sensors give you a little more to work with. I personally still prefer just having a trip point where it's like, hey, if this is changing, I get an early warning, yellow light comes on, and if it continues, then a red light, and just kill the interlock. Don't worry about folding backward. Just get the RF out of there. I've seen too many places where we've watched transmission lines and even the Teflon inside melt, disappear. It's black. It's just like, wow, what a mess. As to Paul's point, it's better to get off the air fast rather than blow up the system and all of a sudden find out you're off the air because, well, that 3.5-inch line takes a little doing to get back in there, or maybe that cavity that's now melted has to be brought in and retuned, and the entire system needs to be worked on. That takes days. And I know that because working with the folks from RFS on a repack project here in New York City, we ran into a few hiccups with tuning and transmission line lengths and impedance miss, all kinds of stuff. So you want to have a good quiet system, make sure it's intact, and monitoring it at all times. And group delay, return loss, VSWR, a few things. You control it, you keep an eye on it, go for it. Manufacturers, yes, Paul's right. Everybody's got a different way to approach it. It sometimes works great for smaller operations, but large installations can be a little dangerous as far as things not going the way you want. So I look at it early and say, hey, look, there's something going on. Good, let me know. And I'll get into it faster rather than wait for it to just say fold back and then call me. No, don't do that.
Yeah.
And Kirk,
Paul,
I think you have a picture of some burnt Teflon, which might be a timely thing to put up.
We do. Actually, we're gonna hear from one of our sponsors right now, but coming up after this commercial, Paul, and audience, we are going to look at some burned Teflon, and it's amazing how hot it has to be to burn. But also, I've got a question for Paul, and I know he can answer this right away, but here's my tease for after the commercial break, and that is, Paul, I want to understand if there's some way to tell the difference between icing on the antenna and, hey, let's just fold back and keep operating because nothing's actually wrong. We're just slightly out of tune. We don't want to blow anything up. And the difference between that condition and a condition where, there's a problem, we're going to fold back, but in folding back, we're going to maintain the arc or maintain the problem or continue burning something up. And I want to understand if there's a way to tell the difference in these two things. So Paul, hopefully I'm sure he will. We'll have an answer for that coming up on This Week in Radio Tech. Hey, you're watching episode 503 of This Week in Radio Tech. I'm Kirk Harnack in Greenville, Mississippi, and Chris Tobin is in New York City. Hey, our show is brought to you in part by our friends at Angry Audio. Angry Audio is now fully manufacturing the Studio Hub adapter line. This is awesome stuff, and all about Studio Hub. It lets you connect quickly and easily between Cat5 cable, which is quick and easy to run, has great common mode rejection. You can get it shielded if you want shielded Cat5 cable, and then it lets you plug into your professional interfaces like XLR or quarter-inch tip ring sleeve, bare wire. You want that. Here's something that you should know. I'm talking to you, Mr. Engineer, my friends, my colleagues, people who do engineering like I do. You probably do a lot more of it. And that is, you can buy adapters like this out there on the marketplace, and they may cost a little bit less, but no more. Because there's now a sale on Studio Hub adapters. you can get 20% off Studio Hub adapters. It's the Get Real promotion. Use promo code GetReal20 and get 20% off all the Studio Hub products. And that brings Studio Hub adapters right in line with the price of, let's say, the cheaper adapters. Do you really want to suffer an engineer coming by your place and say, hey, why'd you get those cheap adapters? You could have had Studio Hub. You could have had the real deal, the genuine deal for the same price. Okay, I'm being a little dramatic, but it's true. You wouldn't want somebody to come by and see that you use some cheap and knockoff and who knows what. Studio Hub is the real deal. I mean, look at the way the stuff is built. It's got these molded connectors here that just will not, they'll put up with years of abuse and twisting and flexing. The machinery that was designed by the Studio Hub people and is still used to put these together, really high quality stuff. And if you look at the other end too, they do a great job of putting, say, XLR connectors on here. And they're really just well done, good quality stuff, good quality. What's the word I'm looking here for, Paul? When you take a cable and you make it so you can bend it and it won't break right there. There's a word I'm not thinking of. I'm sorry.
Resilience, maybe.
Strain relief. Maybe it's strain relief. Yeah, that's the word I'm looking for. So anyway, check it out. You can go to studiohub.com and see the full line. And with your dealer, when you talk to your dealer, say, hey, I want that 20% off. I want that 20% off all genuine Studio Hub products. Just tell them, get real 20, and that'll tell them that we sent you. Hey, look at their ad here. If you're watching on TV, would you buy Microsoft Wind cows? No, you probably want Microsoft Windows if you want an operating system. So funny ad. Check it out. 20% off all Studio Hub products with Get Real 20. Let's get the real stuff for the same price as the knockoff stuff. Thanks a lot, Angry Audio and Studio Hub, for sponsoring This Week in Radio Tech. Hey, I'm Kirk Harnack with you, episode 503. Paul Shulins is with us. So, Paul, what about my question? How do you tell the difference between icing on the antenna and an actual problem? One, I'd rather back off for. The other one, I want to shut down and not make an arc welder.
Yeah, and by the way, this Cat 5 stuff is great. I mean, you can see I'm using it in my application. It's all over the place. Really good stuff. To answer your question, it all depends on the type of transmission line and system that you have and the physics of it as far as how much power you've got coming back and whether that is going to exceed the dielectric constant limit of the transmission line. So are you going to get an arc? Usually in cases where antenna ice occurs, not all cases, but in most cases, they're smaller antennas because an inch of ice on a small antenna is a greater percentage change than an inch of ice on a big master TV antenna or radio antenna.
Yeah.
And typically when you're dealing with smaller antennas, you're dealing with smaller powers, which gives you a little more comfort and leeway that you're not going to burn something up, but it's never a guarantee. When you see the VSWR starting to creep up and you know the weather is bad and you're likely to get icing, then of course, you know, you're suffering from not a transmission line problem, but an icing problem on the antenna that's detuning the transmitter. Not that that is a good thing, but usually with the lower power levels, you've got some leeway there. And it's good that the transmitter does fold back. The kind of problems that I've been experiencing that you see right here on the screen right now that can do some serious damage are with higher power levels and not as much tolerance. And these problems are with TV antennas and radio antennas that do not ice up. What happens here is typically over time, the resistance of the transmission line changes because of the bullets that connect the 20-foot sections together. They're always moving, unfortunately, because of expansion and contraction over the years and with the weather and thermal problems. And sometimes after a long period of time, in fact, I won't even say sometimes, I'd say all the time, after a long period of time, they are going to deteriorate. And eventually, the resistance will become so high that the heat dissipated in that connection can no longer sustain the Teflon or even the copper. And what happens is this stuff melts. And you can see here on this slide, Teflon melts at about 620 degrees, which is absolutely no problem for 100,000 watts or even 50,000 watts of power to produce. In fact, we've had incidences where the copper has melted, and the copper melts at something like 1,000 degrees Celsius. So there's some
Wow.
severe energy that goes in there that can really do damage. And what happens is, if this is at a point that's high on the transmission line, high on the tower, all that soot and smoke and Teflon starts to drip down straight down the transmission line. So you don't just have one little section you have to be replaced, but you might have 10 or 15 or 20 or more sections. And you can see that would get into a lot of money and time with a tower crew to go ahead and do that also. That's why it's so important that people pay attention to these VSWR, and particularly keeping their transmission lines pressurized, because when you have nitrogen or dry air in the line, it increases the available resistance in the air, so that arcs don't occur as easily. So it's a really big deal, and unfortunately, I've seen a bunch of these disasters occur, and so has Chris. And a lot of them are infant mortality type things, where you put the stations on the air on a brand new antenna and something isn't quite right, and these problems tend to crop up right away, which is never a good thing, but I suppose it's a better thing if the tower crew is still on site and they can fix it right away. So like Chris says, it's one of these quiet things that a lot of people don't talk about, but it's a serious problem when it does happen, and it's worth taking steps to protect your investment, whether it be a master antenna system or just a single station. And Kirk, you alluded to some earlier systems. We used to have, and some people still do have, the watt watcher type things where it'll just click off at a certain reflected power level, and those are great to have as well. In fact, I always made sure that they were installed and more importantly, working. You put these things in and you wait 5 years, and maybe it'll work, maybe it won't. So, on a regular basis, maybe every 6 months or every year, you test it out and you make sure it trips off, and make sure none of the wiring in your house has changed such that it's not hooked up to the interlocks anymore, because it's a ticking time bomb waiting to happen if that's the case. So it's important that these systems be maintained, and with a group of broadcasters, it's important that someone is leading the charge, so to speak, and managing the multiplexed operation, getting all the guys together on an annual basis to test the interlocks and talk about how the system is performing and whether we want to get the antenna inspected this year and all that kind of stuff. So there's a lot that goes into it, because it is a big investment.
You were talking about the reflected power reading and the watt watcher kind of way of doing that. Yeah, familiar with those. Is there a way to simulate that an engineer like me could simulate a small rise in reflected power to test something like a watt watcher or something like a more sophisticated system like you might put in? It seems like I would occasionally grab the rotatable sample slug and turn it a bit, and thereby pick up more sample in the other direction. Is that a valid way to test for a trip point, or is there something better?
Well, you can do it. It's not a precise way, but it's a good idea to test these things. Whenever you do something like that, you want to do it at a time when it's safe. Obviously, you're not going to interrupt the broadcast, but also do it with lower power levels, so that if something does go wrong, you're not going to have an accident and burn anything up. But to answer your question, yeah, those rotatable slugs, for the reflected power, if you turn those a bit, it'll give you more of a forward reading, because that's what they are. They're directional, and there's a certain directivity to the directional coupler that's determined by the slug with those watt watchers. So yeah, you can do that. Another way to do it, not recommended, is you can detune the transmitter at a lower power level and see the reflected power come up there. And of course, the watt watchers, the older ones anyway, had those mechanical needles. Remember those red needles?
Yeah.
You could stick a greeny screwdriver in there and turn it so that it trips, and at least that tests the mechanical relay inside the watt watcher, and that can show that your wiring is okay.
Well, about turning the slug, I guess I've used that technique before to try to calibrate a remote control sample. because if the reflected power is really low, I mean, how do you know if your remote control sample is reading something kind of right? Now, maybe your system would be much more sophisticated, but I remember I would, give myself some apparent reflected power by turning that slug, giving more sample back to where it was something that I could at least read, and then I could calibrate my remote control to something a little bit higher, put the slug back, and I had some assurance that it was also reading correctly lower. Again, valid technique, or that seems rather unsophisticated, but maybe it's a decent way to do it.
Well, and a lot of these watt watchers have forward and reflected power meters, and if you have a reflected power meter, you can just look at that and use that to calibrate your remote control with. What I do is I have a precise watt meter that connects to the directional coupler, and the directional coupler is stamped with a calibrated value from the factory, and I can measure the precise wattage that's coming back for reflected and forward, and that's how we calibrate these, as you say, more sophisticated systems right to the watt. But if you don't have that, it's kind of tough. You've got the transmitter meter, the reflectometer, but those are notoriously inaccurate for both forward and reflected power, but they do give you some kind of indication of what's going on there. But I would say, for reflected power, it's best to have a watt meter that is calibrated for both forward and reflected. Chris, do you have any thoughts on that?
I think Chris has already headed out. He's not here now, so it's just you and me.
Okay,
I know.
We're flying solo now.
And it's funny, Chris, Paul, you and I have very different experiences. I mean, I've never worked, I say never, I do have one combined system, and I had another one, but I don't have a multi-station. We typically combine two transmitters. You work in these, high-profile areas where you've got stations that can't go off the air. I got stations I could take off the air for 5 minutes during the middle of the day if I need to, in much smaller markets. I try not to, but so I know I keep harkening back to this. How do I calibrate my reflected power? Because I like to read it remotely, especially if I know there's been an ice storm or an ice storm's coming. I'd like to know, hey, how's that antenna doing or not? And it reminds me of how would one calibrate a speedometer on a car if all you ever did was drive 2 miles an hour? Right. So that's the problem of calibrating in the field at a small station without sophisticated gear. How would you calibrate? Your remote control, so you're reading something when again you're barely getting any kind of a sample back because your reflected power is thankfully low.
Yeah, and keep in mind. Yeah, I'm sorry. Go ahead.
Oh, no, you go ahead and finish your thought, and then we're going to break after that.
Okay. No, to answer your question, the best way to do that, of course, is with a calibrated watt meter, where whether it be a bird watt watcher or having someone like myself come in with a meter and put it on the reflected port if I knew the coupling value to get an exact value. But keep in mind, the real important thing here is the ratio, not the absolute values, but the ratio between the forward and reflected, and that's what actually determines the VSWR, and that's what actually is important to you to understand how much energy is available to produce heating and produce bad effects in the transmission line. So it's really the ratio between the forward and reflected, and not the absolute values.
That it's an interesting concept with our transmitters. The transmitters are happy when they're feeding into typically a 50 ohm J0 load, a non-reactive load, but the transmitter doesn't actually know if the power it's putting out is getting emitted into the air, into our world, or if it's being, eaten up as heat somewhere. And that's your job, to make sure that, hey, this is getting out into the real world and not just burning up as heat. Interesting concept. And hey, so speaking of heat, how about that for a segue? We're going to get into Paul talking about thermal imaging and some very sophisticated stuff. We've got a picture of a drone to show you that will just blow you away. It's in the waiting, it's in the wings. We're going to be coming to that. You're watching This Week in Radio Tech, episode 503. I'm Kirk Harnack. Chris Tobin had to go on another project. We were glad to have him along for a few minutes. And Paul Shulins, who's the president of Shulins Solutions, is our guest. Paul is doing consulting on his own and just a great. If you get Paul to do your consulting, you're going to have a good time, or he'll tell you what's wrong. You'll find out what you need to know the easy way instead of the hard way. Hey, our show is brought to you in part by our friends at Broadcasters General Store and at Vox Pro. We'll be right back.
Yo, what's up? Live from NAB 2018. Hey, it's Caden. You need to check out Wheatstone and Vox Pro 7.1. The upgrades are amazing. If you're a jock, if you're a talent, producer, whatever, morning show, everyone knows Vox Pro, everyone uses Vox Pro, everyone loves Vox Pro. But now the features for this year, 2018, on 7.1 are amazing. If you're using version 4, 5, 6, and you go to 7, this is exactly what you're missing right here. The features are a game changer. It's going to cut down your editing time by like 80% depending on what you use Vox Pro for. And with version 7.1, introducing unlimited Practic button bars right here, hotkeys right here. I'm going to show you coming out of a song.
Bad things. It's a lot of bad things that they wish and they wish and they wish and they wish.
So you're coming out of your song?
Yeah.
Start your next song right here. It's basically an entire production room right on Vox Pro. So it's the Vox Pro we know and love with a ton more features. And now this is the ultimate game changer right here. Effect macros. So instead of hitting your effects button bar and going up here using your mouse for every effect, you do it right here with one click of the mouse, and you're going to cut down your editing time by about 80% without even touching this new sexy black controller. Check it out right here, Wheatstone Vox Pro 7.1 at NAB in Vegas 2018.
Broadcaster General Store is where you can pick up Vox Pro and lots of other broadcast gear. Contact Broadcaster General Store. Their website is bgs.cc. bgs.cc, or call them. And I've had this number memorized for 30 years, 352-622-7700. That's 352-622-7700. They got lots of great stuff, and they have a terrific way of, you place the order, hey, call them up. They're just friendly. They work with you easily on the phone to figure out what you want to get, what they can get quickly for you, get you the best price, sharp pencils and all that. And they have a great tracking method to let you know when your equipment is going to arrive. I call them all the time. Broadcasters General Store at bgs.cc. Thanks for sponsoring the show, Vox Pro and BGS. All right, we're talking to Paul Shulins. And Paul, I met you back when you were with Greater Media was that in Boston?
Yes, as a matter of fact, it was. We did that studio consolidation thing back in, was it 98 or something like that? Kind of dating ourselves there, but it was a lot of fun, a great run. Milford Smith, the director of engineering, boy, what a great guy, and really propelled my career and allowed us to do a lot of fun stuff, including buying a lot of Telos product.
Yeah. Spinny's always been a good friend of my employer, Telos Alliance. So we've talked about these VSWR protection systems, and one thing I want to clear up, make sure I understood. It looked like you are measuring forward reflected power at numerous different places in the system, and that gives you the data that you need to make a decision as to what to do. Again, shut down an individual station or shut them all down. Did I get that part right?
Yeah, that's right. So if it's just a problem at the input to the combiner and only one station is really having the problem, it'll shut that particular station down and let everybody continue to broadcast. If it's on the output that's common to all the stations, of course, we don't know exactly where it is at the moment, but it will shut all the stations down to make sure that everything is safe. In fact, there's one other product too that I wanted to touch on. There's a newer technology that uses time domain measurements to actually tell where the problem is on the transmission line, because you got 1,000 feet of transmission line going up the tower, and you have a problem. Well, where do you tell the tower crew to go to find that problem? And so there is new technology that I'm using and partnering with. There's a company called DAC, D-A-C, and they're out of Switzerland. And they make this sensor that goes inside the building, and the transmitter building, that is, and can actually give you a reading of how many feet up the tower your problem is, so that when you get these expensive tower climbers to climb and take the thing apart, you're not just guessing at where the problem might be. You've got a pinpoint accuracy to within a few feet of where the problem is. So it's really neat technology, and this is kind of full-time monitoring, so that if something is starting to deteriorate, you can get an indication before something bad happens that, oh, there's a problem at 722 feet. We better take a look at that.
So let me make sure I understand. Are you saying that this time domain reflectometer, TDR technology that they have, that DAC has, can this operate in real time with power going on, with the stations on the air?
Absolutely. Yes.
Oh.
Yes. It's full time. It's designed for both radio and TV, and stations are starting to install it now to keep an eye on the health of the system. And it integrates with what I'm doing with the computer as well. They have a web interface for their part of it, but I'm actually using their RF sensors, and just wanted to mention that because a couple of other companies have that technology as well, but I think DAC's pretty much got it nailed down. So it's all good stuff.
At first, when you were describing this, I'm thinking, well, wait a minute. We've been doing TDR technology for years and years. We could tell where the problem was, but that's with all the stations turned off the air and hopefully not too much junk coming into the antenna because the signal was small. But you're saying with this DAC technology, it happens in real time with the transmitters on, and you get a look at the line there. Do you get all that aberration up there where the antenna is? Do you see all that craziness going on the display?
Yeah, absolutely. You see exactly what's occurring there, and it actually looks for arcs as well. And the neat part is, it detects this stuff before there's a problem, so you can react to it. It'll talk to my system, and it'll email you or alert you to something that is deteriorating. And sometimes these things deteriorate over a period of time, whereas that's really where this stuff is valuable, because if something deteriorates over a week or a month, you can catch it, way before it's a serious problem. And the neat part is you don't have to go on the tower to install it. It's just a transmission line section that's inside the building. So it's pretty exciting stuff. It's called the RF Hawkeye, and that is their brand name for it. And it's good stuff.
That blows my mind. I'd like to understand how that possibly works. How can it do that with all this other RF blowing by that line section at the same time? It just seems like the signal would be overwhelmed, but I'm sure there's a secret to it.
There is, and they use full-time signals that are out of the band that still comply with the FCC Part 15 rules that allow them to look at those signals. So it's pretty innovative stuff.
Wow, that seems like a needle in a haystack sort of proposition there. That's amazing.
Yeah, because it's so expensive when you bring these tower crews in. You gotta sometimes run them at night when the stations can go off the air, and if they're just hunting in the dark, it could be very expensive to find the problem. So this is definitely good stuff.
Let's have a look at these two tower pictures that were taken. Suncast number 1 there. Okay, where are we at here? What's this?
Okay, so this one just took a few days ago. This is the new ERI. I think it's a 16 bay. I can't remember how many bays, but it's up on Tiger Mountain in Seattle. And there are 6 FM stations going into it. A couple of years ago, they had a bad burn up on this system because they didn't have working protection, and now they do, of course, with what I just installed, and we hope they have many decades of good service from this. But this is a spectacular mountain site. If you've ever been up to Tiger Mountain, you know what I'm talking about. You look one way and you see Mount Rainier, you look the other way, you see the city of Seattle, and it's just an ideal site up there. They do get a lot of snow and ice, I think, at that altitude. It's not terribly high, but high enough so they do get some of the icing there. But it's a beautiful installation. It was just completed by ERI a few days ago.
Wow, that's 16 bays. You don't often see that. That's a lot. Wow.
No, and it's split upper and lower, so that if there's a problem with one half, they can put the power into the other and stay on the air.
Oh, so normally are only half the bays used, or half the stations on 8 and half on the other? How's it normally set up?
No, so there's two transmission lines coming down the tower. One powers the upper half, one powers the lower half, and there's an RF patch bay inside. So normally the full power of the combiner goes into a hybrid splitter, and each side of the splitter feeds one half of the antenna. But in the event one half of the antenna fails, you can move these big patch links and just feed the good half.
Yeah. Wow. Okay. And where would in a system that you design, that you supply, where would the farthest away VISWR detector be? It wouldn't be up the tower, would it? It's still in the building at the bottom, right?
That's right. That's right. I mean, unless you use, and if you use something like the RF Hawkeye, that would still be inside the building. My detectors are at the output of the combiner. That's the furthest out.
Okay. So would you have one detector on each of the two lines running up?
Yes, and also one before the hybrid splitter, which is the main output of the combiner.
Right. Yeah. So that sounds like three detectors plus one for each station as well.
Yep. And if that's not enough for you, the folks from DAC, they actually have detectors that will go up at the antenna location. And that's another product they have. So I've put in a few of those. The actual signal comes down by fiber optic cable. It's pretty interesting stuff.
That makes sense. Let's look at this other picture, this infrared picture, number 2, Suncast. Picture number 2. Is this a different tower or the same tower?
This is a different tower. This is a UHF TV antenna, and like you said, I'm using drone technology with pretty sophisticated infrared cameras to measure the surface temperature of different points on the antenna and the transmission line. And there's a bunch of science behind this, and I'm getting certified now as a level 1 thermographer, which means that I can read these things with some degree of intelligibility. But basically what you're looking at here, Kirk, is the temperature of different parts of this UHF TV antenna. And the red part is actually a harness. It's a power divider that's behind the radomes inside the antenna. So this gives you an idea that you can really see the sensitivity of looking at a transmitter antenna and see where the different heating points are. Of course, you have to do this in the evening after sunset or before sunrise so that the solar loading isn't, washing all this out. But you can see pretty clearly where that red spot, and there's actually a couple of red spots are, and that shows, expected heating where the power dividers are. But of course, the big advantage here is to go and look at the entire transmission system with the drone and record all the little temperature differences along the transmission line and the antenna so that you can compare that on a regular basis so that if something changes, you'll know that we better look at this. Maybe one of the bullets is becoming loose or something like that, and you see these temperature changes and you go after it.
So I'm saving the drone picture for last. So the next picture that we want to see, number 7 here, Suncast, is the takeoff area. This is the airport.
That's right. Yeah, and what you're seeing on the surveyor tripod to the right of the drone is a system referred to as RTK, and these allow the drone to operate in more harsh environments. A lot of other industries have application for this, like high-tension power lines, but basically I'm flying this thing 20 feet from a 100,000-watt antenna that's radiating RF all over the place, and we don't want it to affect the drone's control. We don't want it to fly into the tower or out of control or anything like that. So this RTK device that's sitting to the right on the surveyor tripod actually triangulates its position from GPS satellites and gives the drone a lot more accuracy and stability when it's in harsh environments. So it actually works pretty well and allows the drone to be very stable and get those really sharp infrared and visual pictures.
So is that drone, I guess we ought to go take a look at the drone, the next picture, number 8 Suncast. This is amazing. This is so much more cool than the little drone that I've got. Look at this thing. Now that looks like some black ops right there. Did you get that from the CIA?
Law enforcement does use this. They do all kinds of crazy things. They have grappling hooks they put on these things, and you can drop life preservers to people that are stranded in the water and all this kind of stuff. But what you're looking at here is the two sensor cameras, which are actually as expensive, if not more expensive, than the drone. The one on the right is the infrared camera, and it's got also a 4K RGB visual camera on it. And the one on the left is something called the X30, I believe it is. No, Z30, I'm sorry. And that thing has a 38 times optical zoom on it. And, even when you're 15 or 20 feet away, I think we have one more picture in here that shows some of the visual images that I was able to capture with this. So if you're trying to do a tower inspection, you can look at a bolt and have it fill the screen, and you can actually count the rust flakes on the bolt. So it's even better than, in some ways, than having a human up there.
Somehow I missed getting that picture in there. That picture is in your brochure, isn't it? Also,
it is. Not? Yes.
Okay. Okay.
It is. Yeah.
I'll put a link to the brochure in the show notes, and I could put a link to these pictures as well, make a photo album so that people can go back and review these, because that is an impressive picture. I'm so sorry that I didn't get it in this. But yeah, my drone, you're, safe distance, 12 feet away or so. And no, you can't see the rust flakes on a bolt. You can tell there's a bolt there, but that's about it. But yes, it's really impressive to be able to zoom up 38 times and see, oh yeah, I can see where the guy nicked the corner of the shoulder of that nut right there. That's pretty amazing.
Yeah, it really is cool. I mean, I look at cotter pins in guy wire cables and stuff like that, and you can clearly see whether they're coming out or not, and of course, it's always better to have a human up there, but this is so much more, easy to do. It's less expensive, and it's safer, really. You don't have to worry about humans going up there all the time, and it's an all-weather type thing. Believe it or not, you can fly this drone in the pouring rain, and it's waterproof, and that's something you don't want to do with a tower climber. So it's neat technology and crosses a lot of industry lines. It's a lot of fun.
So one of the things that I bet you can look for pretty effectively that I'd like to see is look for the pinholes in radomes or in antennas themselves that are made by lightning strikes, because then you either get a gas leak there, or if it's an unpressurized portion of the system, like a radome, or like I guess there are portions of say ERI antennas that are non-pressurized, and other ones too. There's portions of the metal that aren't pressurized. You could go look for those lightning strikes, which will get water and moisture inside those things. So
that's right. That's right. And then you can send someone up to deal with it. Yeah, tell them exactly where it is.
Yeah. Oh my goodness. Wow. So next we need a camera that shows you the F coming out of each bay. See, and then you could tell if you got a bad bay, or what if you could have polarized pictures so that you could tell, hey, somebody installed a bay upside down. That's happened before, right? Oh look, that one's green, the others are red. Wouldn't that be cool?
Well, that's the other thing with drones these days, is the antenna pattern measurement, and they are catching a lot of problems with installations. If the pattern isn't quite right and the antenna orientation is off a little bit, you might not be covering the geographical area you want to cover. So that's a whole nother field that I haven't really gotten into, but there are some experts that do those kind of measurements with drones a lot more efficiently than you can driving around in a car, or a lot cheaper than you can do in a helicopter.
That Rtk technology, you and I talked yesterday about this a bit. I'm still not quite understanding exactly how it works. So maybe you remember that differential GPS that was being supplied. It was supplied in our area right here in Mississippi, such that ag pilots could have more accurate flying patterns, so they wouldn't double spray or overspray a field, or wouldn't miss a section either. So they had a GPS, and they also had a DGPS signal coming from somewhere nearby that would give them that. And I guess regular aircraft could use differential GPS. So is Rtk anything like DGPS, or is it totally different?
It's not totally different. It's similar. What Rtk does is it takes the mostly it's useful for the magnetic sensors, because when you get into electric fields with power lines or RF towers and stuff like that, what happens is the electronic compass in the drone gets messed up. So by taking the compass away, excuse me, from the drone and putting it on the ground away from metal, you're able to transmit those signals to the drone and give it actual better positioning. But it also does a much more accurate GPS down to the centimeter level, and that's part of what RTK is. There are different ways of using RTK. There are public utilities in every state that publish these differential corrections. And you're right when you say differential corrections. And you can subscribe to these services. In some cases, they're free, and you pick them up over the internet, or if you have a hotspot with your drone, you can, if your drone accepts those kind of corrections, you can put them in. One problem I've had is the RTK sometimes takes a long time to lock up, and it's not quite as sensitive as I had hoped in all cases. You need kind of a wide open area. So a lot of times what I'll do is use these corrections that come in over the internet and use my phone as a hotspot to get those.
So, by the way, I think Suncast will be back in a second to fix the picture. When the Matice, I guess is how you pronounce it, drone from DJI came out, they were advertising it as good for doing inspections. They were showing things like bridge inspections, looking for cracks or looking for places where the paint was peeling off and things could start rusting on public transport areas like bridges. And it was important to be able to go back and get to the exact same place you were before within a couple of centimeters. And I guess that was part of the RTK, because if a drone is underneath a bridge, well, it's not going to get really good GPS signals at that point. Can the RTK help with that situation when you don't have great GPS signal?
Exactly, and what I was just referring to with you can locate the RTK in some cases miles away from where you're flying the drone, as long as the signal can get back to the drone because it's line of sight. And if the drone's up in the air, it's going to work. But in other cases where you can't locate the RTK base station, you can use these other corrections I was referring to through the internet. And in many cases, that's a free service from a lot of the different states. They have these receiver nodes all over the place, and you can tap into those, and that's how you get that very high accuracy. In my case, I'm not really interested in centimeter accuracy. What I'm interested more in is stability, because I'm looking at the transmission line, and I want to be able to have a clear picture of that. And if the wind is blowing, it really helps stabilize the aircraft. So that's
and 1,000 feet up, the wind is always blowing.
That's true.
It's never not blowing. Yeah.
True.
Hey, Paul, we're gonna have one more quick sponsor announcement, and when we come back for our last little bit, just a quick segment. Paul, this is your warning that I'm looking for a tip of the week. So you're talking to plenty of engineers, rural engineers, medium market, big market engineers, and I'm looking for a tip or some advice, maybe a website, maybe your website, maybe you've got some resources to talk about. So I'm looking for a tip when we come back. Here's my tip. This is the beautiful Max Connect wireless service from our friend Josh Bone. Josh is a broadcast engineer just like you and me, but he was sick and tired of taking his cell phone out and thinking, hey, I've got really good up and download speeds here, and then the packet loss was intolerable. For live video, live audio, packet loss is not what you want. Every packet's got to get through. We're not talking about downloading email when we're talking about a live broadcast with live audio or even live video. With email or file transfers or loading a web page, that uses TCP/IP. And if the web page takes an extra 3 seconds to load because of some slowness in your broadcast, in your LTE4 connection or your connection with your phone, no problem. The web page is going to load. But for live audio and live video, you need every packet to get through. Well, that's where Max Connect Wireless really helps you out. Now, Max Connect Wireless isn't a modem. I mean, this happens to be a cradle point modem, and they work fine. There are other brands of modems that Max Connect Wireless can use as well. And you may call about using your own modem too. But what Max Connect Wireless does is they are a provider. They are, I think the letters are APN. With Max Connect Wireless, you get the SIM card. And this one has 2 SIM cards. It's got one for Verizon and one for AT&T. And the point is that you get special handling of your data when you're using MaxConnect Wireless. You're not in contention with everybody else in the football stadium or at the tailgate party or at the parade or at the car dealer, wherever you are. You're not contending with everybody else. You get your own data channels, and you have priority over all those other people. And you have priority all the way through the system, the radio channels and the backhaul all the way. Your packets will get where they're going with MaxConnect Wireless. So give these folks a call or check out their webpage at first. It's spelled funny. It's maxconnectwireless.com. And you can choose your carrier. You can choose your plan. A lot of folks are using these for backup to the transmitter site. So you get to the transmitter site, you need backup remote control or main remote control. It can work for that too. We're lucky at my stations. We have got wireless ISPs now to all of our transmitter sites. But for backup, MaxConnect Wireless would be perfect for that. And for going out and doing live remote broadcasts, stations have this in their Go kits. They take them out, they can do live remote broadcasts, and be assured of good coverage with MaxConnect Wireless. By the way, most of the LTE modems give you a wired connection or a Wi-Fi connection. This one does Wi-Fi as well, but hey, if it's right there, you might as well be wired for that assurance too. Check it out at maxconnectwireless.com. I really appreciate Josh Bone putting that service together. It's working for so many people, and literally hundreds of broadcasters across the U.S. and now in Canada too are using MaxConnect Wireless. All right, it's Kirk Harnack along with Paul Shulins. We're finishing up episode 503. And Paul, have you had time to think about a tip of the week for our listeners?
Of course. And by the way, with MaxConnect, I just want to let everybody know that I am using a ton of those for this VSWR protection stuff, and they work great.
Oh.
So thank you, Josh, for putting that product out. It's all good stuff.
Good to hear.
Tip of the week. When I was on, maybe the first time, I talked about complacency in engineering, in broadcast engineering, and that is something that I still think about a lot. And when I worked for Greater Media, we developed so many systems, and there was so much going on, and we're all so busy with engineering, especially with the staffing levels these days. I think it's just so important for people not to become complacent with some of the systems that they may have put together. A good example was up at some of my transmitter sites. I had, stuff that was happening that I didn't think about every day because it was just pretty reliable. But when something goes wrong, you want to, be able to identify that pretty quickly. So my message to engineers is to try and practice, stay familiar with all the systems that you've had to deal with, both at the studio and the transmitter. And if you think about those things and actually practice them every once in a while, it can help you so much when you're under pressure and you're off the air and you've got to figure out what's wrong. You'll know the system's back, like the back of your hand. So it's important. It's not always easy to discipline yourself to do that, but I realized pretty quickly that I was caught by complacency a few times, and like to save other people from being caught by that if they can just think about practicing to look at how their systems are wired, how they would get back on the air if they see an STL goes out, or how do you switch transmitters, all those kind of simple things that we all know, but we don't necessarily use on a regular basis.
Great advice, and I have been afflicted by the complacency bug myself, even right here at my own radio station. So I figured this out last time I was here. Good idea to practice. And you know what, Paul, you're also a small plane pilot. You know that probably as part of your training, certainly as part of mine, we were taught, hey, if you can't afford to get in the airplane and fly, sit in a chair, close your eyes, and imagine you're flying. Imagine you're grabbing the throttle and moving it up and down. Imagine you're putting the flaps down at the right place in the pattern. And so close your eyes, imagine your facility, maybe a transmitter site, and remember what you've got to do this and this and this, and think, is anything going to go wrong when I do it? Because if you know the thing, you should be able to come up with the whole procedure and make that like rote work, right? So,
yep, absolutely. And walk around your transmitter site and, just familiarize yourself with, the generator transfer switch is over here. This is the light that'll come on, and all that kind of stuff.
I saw, I'm going to give a quick tip myself. I saw something this week that I thought was pretty smart because I've never done it and I should. We have a transmitter site, like many of them, where the building is the front door is accessible from the driveway. But then if you want to go into the tower base area, there's another fence with a gate, and the gate has a padlock. And I'd always have to ask my business partner, Larry, I'd say, Larry, what's the combination for the padlock? And then he'd tell me what it was. Well, our friends at EMF, K-Love and Air One, they're also a tenant at the same site. They put up a big sign on the inside of the locked transmitter building door, on the inside. So you're not going to see this unless you're authorized to be inside the building. And it said tower fence lock combo, and it gave the combo for it right there. So when you're walking out the door, there's the information you need, right? Because you're probably going to, if you're going to go to the tower gate. I thought, well, that's a great place to put that. It's exactly where I need to see it. We need to do the thing that Chris Tobin talks about, putting up emergency phone numbers and such near the telephone. So,
and of course, many of us are familiar with that trick. You don't want to leave your remote control in local, right? So many people have put little lights by the door. So if you walk out of the building and you've by mistake left your remote control in local, the light's on or it's flashing or something, and it says, "Oh, I got to go back and put it back in remote." So that's another good trick that a lot of people are using.
That is. I used to turn around and look and make sure the lights were green at the ones I need to. And of course, I remember to do that only because I left it in local.
There you go. It happens. It happens.
Yeah. Had to get up at 5:30 a.m. to out of the hotel room and go back to the transmitter side because of that. Hey, it's time to go. I'll save a couple of tips for later. We got to go because Suncast has places to go, and we do too. Paul, it's been a delight to have you on. Thank you for sharing your knowledge. And your company that you are running full time now is called
Shulins Solutions. And I can be reached at paulshulins@gmail.com. If anybody has any questions, I'd be happy to answer them. And we want to see all the broadcasters do really well and not burn up any antennas if we can help it. By the way, a quick plug in for Comet Neowise.
Yes.
Yeah, just real quick. It is visible for the next couple of nights if you're watching this live or hopefully right around this time frame. It's in the northwest sky right below the Big Dipper. Get out to some dark skies and look to the northwest right below the Big Dipper handle, and you should be able to see that. Not many people get to see a comet in their lifetime. I've never seen one. I'm going to try and see if I can catch it before it goes away in the next couple of nights.
We've when you've been on before, we've talked a bit about your astronomy work and the beautiful long exposure pictures that you take. We'll have to put that off for another time, and because I'd love to do it. But you take some beautiful pictures. Paul, thanks for being with us. I really appreciate it. Thank you.
Thank you.
And thanks to Suncast, our producer, for being with us on this show and getting all the pictures on the air. Appreciate the Suncast. And thanks to Andrew Zarian, the founder of the GFQ Network. We got to go. Be sure you patronize our sponsors. Tell them that you heard about it here on This Week in Radio Tech. And thank you, those of you out there in the audience who have emailed me and Chris. This week, we've gotten a number of compliments from people. And thank you. That is so heartening. It really makes us want to do the show well and keep doing it, and we really appreciate your feedback. You can feedback to us on the website if you like, or if you know my email address, you can send it to me there or on Facebook. We're on there too. Thanks a lot. We'll see you next week on This Week in Radio Tech. Bye-bye.